Okay, today we're in 7.8, graphing functions. We're going to use one of the tables that we did yesterday in our notes from 7.7. Okay, remember this table that we learned yesterday? Remember this? Where we take the function y equals x plus 4 and we make our substitutions. This is review. Okay, go ahead and get out your notes, 7.7 notes from yesterday, so you can kind of look along with me. So yesterday, we started plugging in these numbers. All right, y equals negative 2 plus 4. Got our output. Y equals negative 1 plus 4. Output is 3. Remember this? Everybody following along on your notes? Okay, and we got our outputs. Now, how do we come up with our ordered pair? How do we come up with the ordered pair, Kat?
Take the domain number.
Yep.
And then you take the output number.
Yeah, you take your input and your output in that column or in that row and you match them together, negative 2 and 2. Okay, and then we came up with all of our ordered pairs. So now today we're going to take that a step further and we're going to take those ordered pairs and graph them. All right, so you should have one of your graphs already labeled. All right, so the first ordered pair on that table was negative 2, 2. So I'm going to plot a point on negative 2, 2. Now I want you to plot the other 4 points from that table. Plot them on your graph. Okay, so we go negative 1 up 3, whoops, 0 up 4, 1 up 5, 2 up 6. Draw a line straight through with arrows on each end, and I've now graphed my function. Now, a couple things about this type of function. There's two types of functions, linear and non-linear. Well, what do you think linear means? It's a line. Very good. Yay. Very good. So we call this a linear function. The last step would be to write which function we graphed. Well, where did I get that equation from? Huh? I got it from, yes, my substitution in my original table. Okay? So I graphed, what kind of function was this? A linear function. Graphed a linear function. All right, and we'll talk more about linear and nonlinear functions in a minute. On your homework tonight, you're going to be given an equation like this. This is clearly a function, and it's going to say graph the function. That's it. Graph it. So where do we start? Well, we've got to start with an input-output table. I'm going to let you go ahead and write a condensed version of your input-output table. You need an input and you need an output. And you can use your calculators and or work it out on paper to figure out what your output will be. Now, yesterday we talked about a standard domain or a standard set of numbers that we use for our input. Do you guys remember? What was it? What were the numbers that I said are these numbers we're going to use a lot?
1, 0, 1, and 2.
So I want you to go ahead and set up on regular paper, okay? So leave your graph paper to the side for a minute. On regular paper, I want you to set up this input-output table for this function. There's already a negative in the function. So I have 10 minus negative 2 when I plug in a negative. Did you catch it?
Yes.
So what happens to a double negative? Changes to a positive. So now 10 plus 2 is 12. I want you to fill in the rest of the table. Fill in the rest of your outputs. Once you do the first 3, you should start to see the pattern. 12, 11, 10, 9, and 8. Now you have your ordered pairs and you can graph. We're not going to graph this one, but if we did, where would our first point go on the graph? It would go at negative 212, negative 111, 0, 10, and guess what? It would form a line. These are what kind of functions? Linear functions. Why? Because they form a straight line. What if I had a function like this and it said graph the function? Now technically, even though I've taught you that we have a standard set of numbers for our domain, which is what? Negative 2, negative 1, 0, 1, and 2. I kind of want to deviate from that whenever I have a fraction connected to my variable. Because what if you multiplied 1 over 3 times negative 2? Are you going to get a whole number? No. What could I multiply 1/3 by to get a whole number? What can I multiply it by? What is it? 3. Can I multiply by 3? Yeah, it's going to give me 1. So I want to multiply these by multiples of 3. And guys, on your homework tonight, it can be, y'all can choose different ones. It doesn't have to be, the same set of multiples of 3. Layla could choose 3, 6, 9, 12, 15. But here's what you don't want. You don't want your numbers to be so big that you have to draw a huge graph. So that's why I stick with a blend of positive and negative numbers to keep my values small. Negative 6, negative 3, 0, 3, 6. You've got to have 5. As long as you have 5, you're good. All right? So, again, this is where your calculator really comes in handy. However, you don't necessarily have to use a calculator. You could do y equals 1/3 times negative 6, which equals negative 6 over 3, and that's negative 2. If you had a calculator, you could just put it in 1/3 times negative 6, and it would give you negative 2. I want you to fill in the rest of your input-output table. What's my next y value? Negative 1, 0, 1, and 2. All right, now I do want you to graph this one. Okay, so we did all that work, and we haven't even answered the question yet. The question said graph the function. Well, we had to do all this work to come up with some ordered pairs to graph. We can't just plot a bunch of random points. Okay, so all this work now to come over here to the graph, and now we can graph the function. You have 5 of these on your homework tonight. All right, so plot your points. You did the hard work, now this is the easy part. All right, hopefully at least. All right, so what's my first point? Negative 6.
Negative 2.
Negative 2. Negative 3. Negative 1. 0, 0.
3, 1.
3, 1. 6, 2. So it's kind of a flat line, but that's okay. And then remember, you've got to, what am I forgetting? You've got to write the function on the graph that you graphed, just so whoever's grading your paper, you can match it up. Okay, so we label, this is the function that I graphed, y equals 1/3 x. 1/3 x. Now, what if, for a minute, what if all I could see is the line? What if all I could see is the line, and I asked you, which, basically, what is the function rule that goes with this graph? What? You're like, how in the world would I come up with that? Well, there's a way, okay? I can look at how my x and y values relate. Okay, the 0, 0, that's not going to help me any, okay? But let's look at this dot. Okay, what is the x and y value? It's over 3 up 1, right? So 3 to 1 6 to 2. On the other side, 3 and negative 1, I can tell that I am multiplying these I'm dividing by a third. Okay, they're all 1/3. Another way that I could test, let's say that I had some options. Let's say I had y equals, this might be easier, y equals 1/2 x and y equals 1/3 x. Here's my two options, and I see this line and I'm like, okay, which one of these functions would match with this line? Well, I need to test. I've got to test a couple numbers. So let's test a 1. So if I plug in a 1 for my x value, 1/2 times 1, what do I get? 1/2. 1/2. So I come over here to my x value of 1, and it kind of is at 1/2. No, it's more like at 0. It's more like at 1/4. Okay? So now let's plug in a bigger number, 3. What's 1/2 times 3? If I plug in 3 here, it would be what? 1.5, right? It would be 3 over 2, which is 1.5. So I come back over here to my graph and I look at my 3 value. It's not at 1.5 though, it's clearly at the 1. So plug in a 3 from my x value here, and yes, that would work out to be 1, and I see that that's where my point is plotted. All right? I know, that's kind of tough, and you think, your book thinks that this is the easiest part of the lesson. I think it's kind of tough to match them up. Okay, so let's look at another one. All right, hopefully it'll make more sense on the next one. What if I had let's say my line goes like this. So look at, you're going to have to test it. Here's your options. It's either y equals 3x or y equals 1/2 x. So let's test an x value. And honestly, guys, I would just use 1. If I plug in an x value of 1 here, what does it make my y value? 3. So what would be my ordered pair? 1, 3, correct? So if this line matches with that function, then the line should intersect through that ordered pair. So let's come over here to my graph. Does it intersect at 1, 3? So then it matches this function. Y equals 3x. Do you see that? So you've got to test some values to see which one it matches. You ready for the easy part of this?
Easy.
Yeah, there is an easy. Now these it intersected through 0, so it made it difficult. But if it doesn't intersect through 0, it's really easy to match up lines with their functions. Let's take this one for example. Okay. Y equals x plus 3. What you see here now is this value right here. This is what I call my Y-intercept. Whatever that number is, that is the Y value that the line will intersect at. Do you see that? So since the line crosses at a Y value of 3, I know it matches with that function. So if I'm given the options y equals x minus 3 and y equals x plus 5, doesn't matter how many options I'm given, I know it's this one because the line intersects at a y value of 3. So let me ask you this. Knowing that, let's erase this line. What if I had this line right here? Which function would it match with? Which one of these choices would it match with, the first, second, or third? How do you know the second? Because the line intersects at a -3, so this is the function that it matches with. Isn't that way easier? Okay, so you can just look for that value right here at the end, match it up with where the line intersects, and you're good to go. All right, so hopefully that'll help you on numbers 2 through 4 on your homework tonight. All right, one last thing. Let me erase all these real quick. What if we need to go back and talk about linear and nonlinear functions? You have 3 choices. It is either not a function, or it's a linear function, or it's a nonlinear function. And the way I tell the difference, okay, is by using the vertical line test. What's a vertical line? It's a straight down line. So let's say you see a function like this. Okay? Can you draw a vertical line through any one of the parts of this graph and it only intersects one time?
No.
Yeah, look, here's my intersecting point right here. Okay, at any one of these points, I can draw vertical lines all over this graph, and it only intersects one time. Do you see that? The vertical line only intersects the graph one time. So I would say that this is a non-linear function. Non-linear. Because it passes my vertical line test. I can draw a line and it only intersects the graph in one place. But let's say I have one like this. So now when I draw my vertical line, I'll draw it in a different color. Now when I draw a vertical line, how many points does it intersect? 2. So this does not follow the rules of a function. It has to be able to pass the vertical line test where it only intersects one time. Because this one intersects 2 times, it is not a function. You're going to have a question like this on your homework tonight. Okay? So horizontal like this, not a function because there's 2 intersecting points. And then last but not least, the easiest of them all is my linear function. Because what do you see here? It's a straight line. And does it pass my vertical line test? Yeah, I can draw straight lines through it all I want, and there's only one intersecting point on each of these vertical lines, so I'm good to go. You see that? Okay. So there you have it. We've actually covered everything you need to know for 7.8.